So this is a question from Newton's laws of motion, in which we are given that there are three blocks A, B, and C, and all the three blocks are of same masses. And the friction coefficient between the blocks is mu, and there is no friction between the blocks C and the ground. And the A and C are connected by a string which passes over a smooth pulley, and we are applying a constant horizontal force F on this pulley. So we need to find the acceleration of B under all possible cases. Okay, so there are many possible cases which can arise over here. So let us look into each of the case separately. So the first case will be, let us assume that all the three blocks are moving together, which means there is no relative slipping between the blocks. So all the three blocks will be having a common acceleration. Now, if I consider all the three blocks as a system, then I can say that the frictional forces between the blocks will become internal force, and the net external force on the system will be simply equal to F. So the common acceleration of all the three blocks should be equal to net external force, which is F, divided by total mass of the system, 3m. So A equal to F by 3m. Now, if you consider only the FBD of block A, so there is a horizontal force F by 2, and there will be a frictional force F1 on block A in the left direction. And on block C, there will be a external force on the right, which is F by 2, and a frictional force F2 on the left direction. And on block B, there will be frictional forces F1 and F2 in the right direction. Now, since the block A and C are moving with the same acceleration, so we can write the equation F equal to ma for A and C, and from that will be able to find out that F1 will be equal to F2. Okay, so we'll get the same value of frictional force because the acceleration is same, so the net external force should also be same. Now, what is the maximum value of F1? F1 static friction, maximum value of static friction F1 will be mu into normal force between AB, which is mg. And for F2, the maximum value will be mu into normal force between B and C, which is 2 mg. Now, if F1 is equal to F2, then we can say that these values should be less than equal to mu mg, right? Because F1 is equal to F2. So again, we are writing F equal to ma for, let us say, block A. Then you will net force will be F by 2 minus of F1 equal to mass of block A, which is m, into acceleration, which is F by 3m. Now, if I write the value of F1, if I find out the value of F1, which will be F by 6, because ma, the value of ma is simply F by 3, right? So F1 will be F by 6, and it should be less than equal to mu mg. So remember that F1, since F1 and F2 are equal in are having equal values, so both these frictional forces will have a maximum value of mu mg, not 2 mu mg. So if I find the value of F1, which comes out to be F by 6, and make it less than equal to mu mg, so I'll get a value of external force which is less than equal to 6 mu mg. So this condition tells me that if the external force is less than or equal to 6 mu mg, then all the three blocks ABC will be moving with a common acceleration of F by 3m, and there will be no relative slipping between the blocks. So this is our first case. Okay. Now in the second case, let us assume that A and B are moving together. There is no relative slipping between A and B, but there is slipping between B and C. So A and B are moving as a single unit and C is moving separately. So if there is slipping between B and C, then the friction between B and C will be kinetic in nature. And again, I have assumed a sub case, you can say that the acceleration of A plus B as a system is greater than the acceleration of block C. So if acceleration of A plus B is more than the acceleration of C, then the kinetic friction on A plus B as a system will be towards left, which is 2 mu mg. And on block C, it will be towards right, which is 2 mu mg. Now, I'm using this inequality that acceleration of A plus B is greater than AC. So what will be the acceleration of A plus B as a single unit? Net external force will be F by 2 towards right and minus of 2 mu mg, which is towards left. So F by 2 minus 2 mu mg divided by total mass of the system A plus B, which is 2m. This acceleration should be greater than acceleration of C. Now, what is the acceleration of C? Net force is F by 2 towards right and 2 mu mg towards right. So F by 2 plus 2 mu mg divided by mass of block C. So if you solve this expression, you will get F by 4m plus 3 mu mg is less than 0. Now, the summation of two positive terms will never come out to be less than 0. So what does this inequality tell me? That this particular case 2 is not possible. So A plus B moving together as a single unit and having an acceleration greater than C is not a possible case. Okay. Now the third case is, so suppose A plus B is moving together and now acceleration of A plus B is less than the acceleration of C. So in second case, we assume that A plus B is having an acceleration greater than the block C. Now we are assuming that A plus B is having an acceleration less than AC. Now again, I am writing the acceleration of A plus B. Now since AC is greater than acceleration of A plus B, it means if C is having an acceleration which is more than A plus C, it means that frictional force on A plus B as a system will be towards right because the acceleration of C is more. So A plus B will have a frictional force towards right, which is kinetic in nature and 2 mu mg. On block C, it will be towards left, which is 2 mu mg. So what will be the acceleration of A plus B? Net force will be F by 2 plus 2 mu mg divided by total mass of A plus B, which is 2m. And this acceleration is less than acceleration of C. So net force on C is F by 2 minus of 2 mu mg divided by the mass of block C. So from here, you will get the value of force to be greater than 8 mu mg. Now, what is the maximum possible acceleration of B? Okay, so you can come look at this part from the first case. So see the block, if the block B is moving towards right, then there is a frictional force F1 and F2 on block B. Now, if F1 is having a maximum value of mu mg and F2 is having a maximum value of 2 mu mg, so the net maximum external force that will act on block B, only on block B, will be 3 mu mg. So the maximum possible acceleration of block B can be 2 mu mg plus mu mg, which is the net force, divided by mass of block B, which is 3 mu mg. So block B cannot have an acceleration which is greater than 3 mu mg. This is the maximum possible acceleration of block B. Now here we have assumed that A and B are moving together. So if B is having a maximum acceleration of 3 mu mg, so A plus B will also have a maximum possible acceleration of 3 mu mg. Right? So we can again use this inequality that acceleration of A plus B will be less than equal to 3 mu mg. Again, what is the acceleration of A plus B? Net force is F by 2 plus 2 mu mg divided by total mass of A plus B, which is 2m. And this acceleration should be less than or equal to 3 mu mg. So from here, you will get the value of force is less than 8 mu mg. So you can see that these two inequalities are contradictory in nature. First inequality is saying that the force should be greater than 8 mu mg. Second inequality is saying that the force should be less than 8 mu mg. So final conclusion tells me that this third case is also not possible. So it means that in this particular question, we can never have a case where A and B are moving as a single unit, which means there is no relative slipping between A and B, and there is relative slipping between B and C. So this particular case is not possible. Okay, so now we come to case 4. In case 4, we have assumed that suppose B and C are moving together, there is no relative slipping between B and C, and A is moving separately, there is relative slipping between A and B. Now again, I have taken a sub case. Let us say that acceleration of B plus C as a unit is greater than acceleration of A. Okay, so B plus C is having a greater acceleration compared to A. So what will be the acceleration of B plus C? If B plus C is having acceleration greater than A, then the frictional force on A which will be towards right, mu mg, because it is kinetic in nature, because there is slipping between A and B. So the friction between A and B will be kinetic in nature, which is equal to mu mg. So on block A, the frictional force will be towards right, which is mu mg. And on block B, it will be towards left, which is mu mg. So what is the acceleration of B plus C? Net external force will be F by 2 minus of mu mg. F by 2 is towards right, mu mg is towards left. F by 2 minus mu mg divided by total mass of B plus C, which is 2m, which is greater than acceleration of A. What is acceleration of A? Net force is F by 2 plus mu mg divided by the mass of block A. So again, this inequality gives me, you can see that the final result will give you F by 4 m. Actually here the term m is missing. So F by 4m plus 3 by 2 mu mg, not mu mg, mu g, this inequality is less than 0. So again, you can understand that the summation of two positive terms cannot be less than 0. So again, this fourth case is also not possible where acceleration of B plus C as a unit is greater than the acceleration of A. So let us now consider the next possible case. What will be the next possible case? That acceleration of B plus C will be less than the acceleration of A. B and C are moving together and acceleration of B plus C will be less than acceleration of A. So let us check the fifth case. Okay, so if B plus C is having an acceleration less than A is having more acceleration, it means that frictional force on A will be towards left, which is mu mg, and on B will be towards right, which is mu mg. Again, from this inequality, I am writing the acceleration of B. Net force will be F by 2 plus mu mg divided by total mass of B plus C as a unit, which is 2m. Less than the acceleration of A, net force is F by 2 minus mu mg divided by mass of block A, which is m. So this expression gives me an inequality where force F is greater than 6 mu mg. Now again, we know that the acceleration of B, maximum possible acceleration of B is 3 mu mg. Sorry, 3 mu g. So what will be the acceleration of B plus C? Maximum acceleration of B plus C should be equal to 3 mu g. So I'm writing the acceleration of B plus C. So net force is F by 2 plus mu mg divided by total mass 2m. And this inequality is less than equal to 3 mu g. So from here, I'll get the value of force as 10 mu mg. So combining these two results, 1 and 2, if the force lies between 6 mu mg and 10 mu mg, then this particular case is possible where B and C will be moving together and having an acceleration less than the acceleration of block A. So till now we have found two possible cases. First case was where all the blocks are moving together as a single unit. There was no relative slipping between the blocks. And the second possible case that we have found till far is B plus C moving together as a single unit, and acceleration of B plus C is less than the acceleration of A. This is the second possible case. And the last case that we have is suppose all the blocks are moving independently and there is relative slipping between all the surfaces. Now, since there is relative slipping between the surfaces, so all the friction will be kinetic in nature. On block B, there will be mu mg kinetic friction towards right, 2 mu mg kinetic friction towards right. So I've assumed over here that obviously acceleration of C is greater than the acceleration of block B. Only then we are having the directions of kinetic friction as shown. Okay. So the acceleration of block B will be simply 3 mu g in this case. Okay. So what will be the, now what is the condition under which you have applied this kinetic friction on block B towards right? We have assumed that the acceleration of C should be greater than acceleration of B. If C is having acceleration greater, then with respect to C, B will be falling behind. So that is why the frictional force on block B will be towards right, which is 2 mu mg. So if acceleration of C is to be written, the net force will be F by 2 minus of 2 mu mg divided by the mass of C, which is m. And acceleration of B is simply, or the net force on block B will be 3 mu mg divided by m. So the m term which is in the denominator of this inequality, that gets cancelled out, and we are getting the value of force F as greater than 10 mu mg. So this is the third possible case. So if the force F is greater than 10 mu mg, then all the blocks will be moving separately. There will be relative slipping between all the surfaces, and the acceleration of C will be greater than the acceleration of block B. So in total, there are three possible cases. First case is where all the blocks are moving together. Second case is B and C are moving together with acceleration of B plus C less than acceleration of A. And the third case is all the three blocks are moving separately and the acceleration of block C is greater than acceleration of block B, and the value of force F should be greater than 10 mu mg. So these are the three possible cases.